83 when we're done. Okay. So we've talked about exponentials. We did most of that before Christmas. Then we've been talking about logs, and we've done different things with them, converted them, dealt with some of the properties. So today we're going to look at them both together and start actually solving some equations. These properties here are 6 properties that we've already looked at, that we have done, that we have remembered from Algebra 2 because they weren't new. And these 6 are the main ones that we're going to employ to be able to solve these equations. So we've got the product property for exponents. You know, if you multiply 2 things with the same base, you add their exponents, right? We know that rule. We know if I have a power to a power, then they get multiplied. And we know if we have a negative exponent, that results in the reciprocal, right? All old news that we get. And then product property, quotient property, and power property that we talked about the other day for logs. Converting between the two, and I will say again, there's a difference between straight up just converting and finding the inverse. When you find the inverse, you end up converting as part of the process, but just plain old converting does not result in an inverse. Okay, so I think some people sometimes get those intertwined or mixed up. So if I'm going from this form to this form, I'm just rewriting it, not finding the inverse because we didn't switch anything, right? And so I know that the base of the base of the exponential becomes the base of the log, and the vice versa, the base of the log becomes the base of the exponential. And you go around in a little circle, either way you look at it. I'm going to have, this is the base of the log, that would be the argument of the log, and that would be the answer. Where this would be the base of the exponential, that would be the exponent, and then that would be my answer. So just, you gotta make sure you go around that equal sign to use all the pieces so you don't put them in the wrong order. Okay, but I think we've got that down pretty well. When we solve them, there's a couple of different things that could show up along the way. And so one of them is when we just have one log. So if we just have one log equal to some number, what do we do? So if it involves only a single logarithm or only a single exponential, we can solve by converting. All right? So when we solve these, here are our steps. We isolate. We'll talk about exactly what isolate means, and now you know it's isolated. Whichever one you're doing on one side of the equation, then you convert the equation to the alternate form. If it's an exponential, you make it a log, and vice versa. And then you solve for the variable if necessary and simplify and or round answer as directed. Right? That means, you have to actually read the directions. That's important. All right, so let's look at what's happening here. And so this says we are going to leave this in exact form. Okay? Meaning that if I get the square root of 17, it's the square root of 17. I'm not trying to find a decimal or anything like that. Okay, so here we have an exponential, and 4 to the x power minus 2 equals 7. This is what I'm trying to isolate here. So I'm going to have, before I do anything, I have to add 2 to both sides. So I'm going to get 4 to the x power equals 9. Okay. Now, if that equaled 16 instead of 9, would you automatically know what x is? It'd be 2, right? But in this case, x is not a number that you're going to know or be able to calculate accurately in your head. You would basically have to have a calculator for it. And so instead of just knowing that it's 2, now's when we're going to rewrite it as a log, because this is now isolated. It's going to be log base what? 4 of 9 equals x. Okay. Now, do you know exactly what this value is? No. And that's fine. Do you know at least that it's just some number? Yeah, and that's what we're going for. And that's an exact form. We're good. If we needed to know it, like this is we have exact numbers and then what I call like Home Depot numbers. Like if I was like trying to fix something in my house and I was trying to get exact measurements and I got that I needed something that was the length of log base 4 of 9, and I need them to cut me something, I can't go up to the guy at Home Depot and go, hi, can you cut this board for me? And he's like, sure, what length? Log base 4 of 9 inches. He's going to think I'm insane, right? I'd have to use a calculator at that point, but that's not what we're having to do right now. It's just exact form. Exact form, the answers don't always make a lot of sense in our brains or, but it's okay. All right, so let's look at B. I need to isolate the exponential, which again is this. So what's the first thing I'm going to do? Subtract 5. Good. So I'm going to get 2 to the x plus 3 power equals 21. Okay. What am I going to do next? Rewrite it. So I'm going to have log base what? 2 of what? 21 equals x plus 3. Am I finished? No. I got to subtract 3 from both sides, so I'm going to get log base 2 of 21 minus 3 equals x. Does that become log base 2 of 18? No, it does not. And if you are not sure or whatever, or to be safe, we can also do this. You don't have to, but a lot of times you'll see the arguments in parentheses no matter what. Sometimes they have to be, but sometimes they just always are, even if it's not necessary. And that kind of makes it a little bit more clear. Either way is fine. Everybody okay with all that? Alrighty. So let's look at C. So this has an E in it. Does that mean it's more difficult? No. E means easy, right? Actually going to have to do probably maybe a little less math sometimes. But I'm trying to isolate the e to the x. So the first thing I'm going to move is the what? The 3. So I'll subtract 3 from both sides, and we get negative 10 equals negative 4 e to the x. Even though I only have one term on the right side, it's not isolated because this 4 is being multiplied by it. So I got to move that negative 4 legally, which means I'm going to divide. So this will give me negative 10 divided by negative 4 equals e to the x. Right. What's negative 10 divided by negative 4? 5 over 2. So I'm just going to change that right there. So I don't have to do it again. Right. Am I done? No, because I don't have x equals, right? Because I'm actually solving now. So what's the base of my log? What's the base of my log? E. So what do I write? ln, yeah. So it's a natural log. The base is e. Natural log of what? 5 over 2 equals x. Then I'm done. That's some number. I don't know what the number is, but it's some number, and that's fine. Okay. Everybody good at this point? Awesome. Flip it over. So now we have logs, and we're going to take them and solve them, converting them to exponentials. So the first thing I'm going to do to isolate here is I want to get this log base 3 by itself. So I'm going to move that 4 first. So I've got 2 times log base 3 of x plus 3 equals 6. Now I got a couple options for that too. I could divide by 2. What's my other option? What else could happen with that 2? It could become an exponent, right? And then I could get x plus 3 squared. So let's think about, would I rather end up with x plus 3 squared or 6 divided by 2? 6 divided by 2, 100%, right? I agree too. So I'm going to divide by 2. So you wouldn't be wrong to do it the other way. You're just going to make your life more complicated. Sometimes you don't realize you're making your life more complicated. That's okay. So we're going to go log base 3 of x plus 3 equals what? 3. Lots of 3's in there. Okay? So then now it's isolated. Now I can rewrite it, right? So what's the base of my base of my exponential? 3 to the what power? Third power equals x plus 3. What's 3 to the third? 27. So 27 equals x plus 3. So x equals 24. Any questions? Awesome. All right. So let's look at the next one. What do I need to move first? The 2. So this will leave me with log base 5 of 2x minus 1 equals 2. So now see if you can rewrite it and solve for x. Okay. 13? Yes? Good deal. All right, let's look at C. What should I do first here? Multiply by 5. So this will give me the natural log of 2 minus x equals 5. So now do I freak out because it's a natural log? No, that's never a step. I need to rewrite it as an exponential. What's the base of my exponent? E. E to the 5th equals 2 minus x. And E means easy because look, 3 cubed we had to do 27. 5 squared we had to do 25. E to the 5th, you know what that is? E to the 5th, and we're done with that. I'm not done with the question though. I need to solve for x, so I'm going to move my x to the left and the e to the 5th to the right. So my x is positive. So x is equal to 2 minus e to the 5th, which is just some number. And you're done. What questions you got? Beautiful. All right, so that's when we just end up with one log, a log equal to a number, and then we can rewrite or exponential like that. But what if we have more than one log? So if we have more than one log, we're going to use our properties to condense things. Then we may end up back with something like what we just solved. That works. Or we may end up with a log on each side. And if we end up with a log on each side with the same base, then we can just make this into x equals y. Okay, that's what's happening there. Couple of notes that are important. In either case, we need to check for extraneous solutions. We really should have done that on the last 3. We didn't because I didn't want to put all that together and those work out just fine, but we're going to have to check them. And the reason we have to check them is that for exponentials, this is what your parent function looks like, right? And your domain is all real numbers. For a log, your parent function looks like this, and your domain is not all real numbers. So if this is what our equation looked like, or our graph looked like, and we solved for something and we got -2 would be an extraneous solution because it's not in my domain, right? But they're not all in the parent function. They have moved, so we have to figure out what the domain is. It's not difficult, but we got to figure it out. The second one is that, so we did say that if this happens, then x equals y. But if you have this, like x, log of x plus log of y equals log of z, that does not imply that x plus y equals z. You cannot just cancel out the logs. Only if you just have one on each side with the same base. Okay. All right. So let's look at this example here. So since they're logs and we should check for extraneous solutions, we're going to look for our domain at the very beginning because you always have to do it from your original equation. Log of 3 is just some number. There's no x in there, so I'm not worried about it. Let's say that I solved A and I got x equals -6. I can look up here and say, I know that's an extraneous solution because -6 plus 4 would be a -2, and I can't take the log of a negative number, right? But we can also just figure out what the domain actually is of this mess by saying we're going to take this x plus 4, and I know whatever that is, it has to be greater than 0. So that means that x has to be greater than -4. Would you agree with that? Then I got to look at the next one. 5x minus 2 also has to be greater than 0. So that means that 5x has to be greater than 2. So x has to be greater than 2/5. So if both of these things have to be true, I can pick just one of them and it'll take care of both of them. Which one would I pick, the first or the second? The second. Because if it has to be greater than -4 and greater than 2/5, then it really just has to be greater than 2/5. So this is my domain that I'm going to check against when I'm done. Everybody okay with that? It's going to work out the same way every single time. All right, so then we're going to start to try and simplify this. I have 2 logs here with the same base. They're being added. So I can change that to 1 log with what? What kind of operation? It would be log of multiplication, right? 3 times x plus 4 equals log of 5x minus 2. Everybody okay with that part? So now I have 1 log on each side. They're both isolated. They both have the same base. So this is like log of x equals log of y. So I can just let x equal y, which means this part equals this part. When I take this left side out, I'm going to go ahead and distribute. So this gives me 3x plus 12 equals 5x minus 2. So 14 equals 2x. X equals 7. So is 7 greater than 2/5? Yes. Then my one answer works. We good? Any questions? All right. Then let's look at B. For the domain, right? So x plus 1 has to be greater than 0. So x has to be greater than -1. And also 3x minus 5 has to be greater than 0. So 3x has to be greater than 5. X has to be greater than 5/3. So of those 2, which one wins out? The first or the second? The second. Kind of for the same reason. Alrighty. So then this is a natural log instead of a log, but that doesn't make anything any more complicated, right? I have these 2 and they're being subtracted, so that changes to 1 log with what? Division. So this is x plus 1 over 3x minus 5 equals the natural log of 7. So now can I take them out of the logs? I can. And I'm going to get x plus 1 over 3x minus 5 equals 7. Then I can multiply and say x plus 1 is equal to 7 times 3x minus 5. So then x plus 1 equals 21x minus 35. 36x equals 20, not 36x, good Lord. 36 equals 20x. So 36 over 20 equals x. What does that reduce to? 9 over 5. So x equals 9/5. So I got to know if 9/5 is bigger than 5/3. There's a few ways to do that. One is to type in the calculator and look at the decimal. You don't get that option. So let me show you a little fraction trick that I'm pretty sure most of you probably don't know. If you're trying to compare 2 fractions, if I'm comparing 9/5 and 5/3 and I want to know which one's bigger or which one's smaller or whatever, if I write them down, okay, and then I multiply diagonally up, so I'm going to multiply this way and get 27, and I'm going to multiply this way and get 25. The fraction that has the bigger number on it is the bigger fraction. The fraction that has a smaller number on it is a smaller fraction. So that means that 9/5 is bigger than 5/3, and that's all I really cared about, so I'm good with my answer. Okay? We good? Any questions? You were probably taught that trick somewhere along the way for some standardized testing stuff, but all right. Let's look at the next one. Okay, so I have on the left being added, so I'm going to change it to multiplication. Log base 3 of x plus 2 times x minus 3 equals log base 3 of 14. Okay. Now, on the left here, I have these two binomials. I may or may not need to actually multiply them. So I'm not going to multiply them until I figure out whether or not I need to. Sometimes we need it in factored form. And you end up multiplying it together and was like, oh, dang it, shouldn't have done that. And then you got to go backwards again, and there's all kinds of room for mistakes. So we just kind of leave it like that until we figure out what's going on. But right now I have one log on each side, so I can take those things out of the log, and I can get x plus 2 times x minus 3 equals 14. Okay, so since I have to solve for x, I'm going to have to multiply them together, right? Just for the nature of the problem. So when I multiply them, I'm going to get x squared minus x minus 6 equals 14. What kind of equation do I have? What's it called? Oh, exactly. This is the hardest question. Thank you. It's a quadratic. Since it's a quadratic that I need to solve, what do I need to do? What do I do? Set it to 0. I got to set it equal to 0. So x squared minus x minus 20 equals 0. Then I'm going to factor x and x. And what are my two numbers? Negative 5 and 4. So that means that x equals negative 4 and 5. We have to find the domain. We don't necessarily have to do it first. I didn't do it on this first just to see if anybody even asked that question. But I think it's good to do it first so that you don't forget that it's important. If we don't do it until the end, like right now, that's fine as long as we do it. Does that make sense? That's a very good question. All right, so here, because maybe both of these are my answer, maybe they're not. I don't have anything to look at because I didn't actually find the domain first, so let's do that. So I've got x plus 2 has to be greater than 0. So x has to be greater than negative 2. And go ahead and do the other one. Okay, thank you. And then x minus 3 has to be greater than 0, so x has to be greater than 3. So this one wins, right? So then when I look at my two answers, are they both going to work? No, because negative 4 is not one of my answers, so my answer is just x equals 5. If you get to this point and you kind of know what's going to happen here and you already have that over there, you can't just write down 5. You got to find them both and then show that you checked, and then it's only 5 that works, right? So make sure you actually do the whole thing. What questions you got? All right, you do the next one. So we can't work this one exactly like the others, right? I mean, well, exactly, some of the others we did, but not the one right before it. Because if you were tempted to write down x over 3 equals 2, that's not correct because I don't have a log on each side. Got to rewrite it because it was only 1. Now, do we know what... Oh, he's not here. Do you know exactly what the value of 3e squared is? No. Are you pretty confident it's greater than 0? Yep, good enough, right? So even if you didn't know what e is, once you square it, it's going to have to be positive. I mean, you know it's a positive number, but if you didn't, so totally greater than 0, we're good. That's our answer. Okay. What questions you got? Anything? Awesome. Grab your other sheet of paper, which is also going on 83. And I'm going to work a couple of more. And I'm wondering if, yeah, so that's a different question than what's on the other paper I have. And so I think we might change B. Sorry, I didn't catch that until we got through it in last period, and it was that one works out strangely. Okay, so on the left here, we've got, let's go ahead and do our domains. So I know that x has to be greater than 0, and x plus 7 has to be greater than 0. So x has to be greater than -7, which means this is my domain. Okay. Alrighty. So am I eventually going to do the quotient property? Can I just do that right now without doing anything else? The answer to that is no. Why not? Look at this guy right here. I can't put the log base 4 of x over 2. Like that 3, I got to do something with it. What can I do with that 3? Convert it to an exponent. Just boop, pop it up there, right? Now, and I can do that all in one step. That's fine. I just can't forget to do that. So I can do log base 4 of x over 2 to the 3rd power equals log base 4 of x plus 7. Everybody okay with that? So now I have one log on each side, and I can take those things out. When I do, I'm going to go ahead and cube 2. What's 2 cubed? 8. So x over 8 equals x plus 7. So that means x equals 8x plus, what's 7 times 8? 56. Thank you. I got one person that knows their multiplication facts. And so that means that -7 equals, not -7, good Lord, -7x equals 56. So what does x equal? -8. Does -8 live in my domain? No, my domain x has to be greater than 0. This is what we got. That's the only answer we got, so my answer is no solution. Everybody okay with that? Yes? All right, so I'm going to change B, and then I'm going to have you work on it on your own. So let's see, we're going to change this to log of, how can I write this? Log of x plus 3 times the log of 2 equals log of 2x minus 7. There we go. Start on that while I hand out the worksheet. Is that Grand Central Station today? Oh, you're done. Thank you. And let me be clear on your work. Remember, your work has to flow. Your steps have to make sense as you go. If when you look at this, you know that when you condense that, you're going to end up with a log on each side, so you decide to go straight from here to here, that's not legal. You have to write this step, and then from this step is when you're allowed to do that. Does that make sense? I see that a lot from people that don't want to show their work, and that's not good because your work doesn't make sense by math law, okay? Everybody get to negative 7/6, okay? So then what's my answer? No solution, exactly. All right, so we are going to spend, that's right. We're going to spend probably the rest of next week on this section because there's more notes that go with this. We're going to stop here for today, even though I know we have 10 minutes left. I want you to get, so you have the assignment. You can get through at least do some of this before Monday, because you know what happens when we come back and work on this. If you have questions, we can go over them. So work on some of it. Challenge yourself. Some of you knew that needs to be a challenge to actually do your work. But what I need you now to do is get your laptops or your computers out, and you do not have to go to Schoology.